Okay, so let us continue with the last part ng ating discussion about heat transfer. So after this, meron akong 10 problems, extra problems para isolve natin siya. So ito na yung next problem. That is problem number 14. Let me just read it first. With three different quantities, X, Y, and Z, of the same kind of fluid temperatures, three temperatures meron tayo, 9, 21, and 38 degrees Celsius respectively. It is found that when X and Y are mixed together, the resultant temperature is 17 degrees Celsius. And when Y and Z are mixed together, the resultant temperature is 28 degrees Celsius. Find the resultant temperature if X and Z were mixed. So this is more of what you call this? Algebra. Okay, algebra ng calorimetry. So, 'di ba pag nag-mix ang dalawang bagay, okay, hindi naman sinabi na kung equal ba yung masses nila or anything, we can have na we can have a mixture na maghahalo-halo yung temperatures nila and then we'll have a resulting temperatures. Okay? So let us just first hanapin natin yung mga values ni X, values ni Y in terms of their masses. Okay? So ilista natin yung temperature ni X. That is 9 degrees Celsius. The temperature ni ayun, ito pala, three different quantities, ibig sabihin, iba-iba sila ng masses pero magkakapareho ng CP, okay? Ty, that is 21 degrees Celsius. Tz, that is 38 degrees Celsius. Now, going back, 'di ba pag nag-mix ang dalawang bagay, equal ang Q niyan, 'di ba? Pero magkakaiba ng masses, pareho ng CP. So, recall this yung CP, okay, T1 minus T2 ay equal yan sa, okay, gawin na nating XYZ, okay. Sabi dito that it is found that when X and Y are mixed together, the resultant temperature is 17. Okay? That is the resulting temperature. Mhm. So, algebraically, MX, okay, CP nung fluid na yon equal naman yon, okay? CP original na lang, CPO. Tapos, probably, itong X, okay, yung pinakamababa. Then, the temperature here, temperature resultant, TR, okay, minus yung temperature ni X, yung kabilang fluid, okay, yung kabila, na ibang quantity, M, Y, CP, O, tapos yung T, Y, minus, syempre, mas mainit to, T, R. Okay. So, we cancel out yung same. O, ito lang naman yung same dyan eh. Tsaka yung CP. Okay? Algebra lang to. So, pagsamahin natin, M, X, equal to TR, hindi, multiplied to TR, that is 17 minus 9 equal to MY. TY is 21 minus 17. Okay, solve natin. MX, MY, 17 minus 9, I think 8MX equal to 8MY. Ay, 8MY tuloy. 21, 4MY. So, divide natin both sides by 4 para may makuha tayong value. So, twice ni MX will be equal to MY. So, this is equation A. Okay? I-reform natin. 2MX minus MY equal to 0. Okay? Yung A natin, equation A. Sa A natin yan. Okay. How about, sabi dito, when Y and Z are mixed. So, MY, tapos TR, yung resulting. TR1 to, TR2 ito. TR2 minus MY or TY equal to MZ tapos TZ minus TR2. Okay? Resultant eh. May dalawang resultant yan. Ano ba yung binigay dyan? 28. So, MY, 28 minus TY, that is 21 equal to MZ. And then, TZ is 38 minus 28. So, further simplifying, MY 7 equal to 38, 28 MZ. That is 10. Okay, 10 MZ. 10 MZ. Yan. So, pwede nating i-reform ito as 10 MZ minus 7 MY equal to 0. So, this is equation B. Okay? Ano pa yung susunod? Okay? We can solve that. Yan. So, ano sinabi dito? Find the resultant temperature if X and Z were mixed. MX, the resultant temperature 3, okay, TR3 minus TX equal to MZ TZ minus ER3. Now, pwede nating isolve dito yung value ni X para maging single out lang to. Okay? MZ lang. Okay, meron tayong i-set aside muna natin to. Okay, set aside muna natin to. Sa equation na to. Pwede nating pagsamahin 2mx tapos yung simplifying natin. Simplify. Equation A and B. In dulo-dulo. So, dito muna tayo magsimula. 10 mz minus 7 my equal to 0. Tapos yung A, 2mx minus 2my. 2mx minus my. 2mx minus my equal to 0. So, dapat ima-minus natin. So, minus mo. Kaya lang, itong baba, i-multiply mo na lang ito ng 7. Or simply, multiply mo na negative 7. Para maging plus. Okay? Pwede na yan. Pwede na yan. Plus 7. So, 10 mz minus 7 my equal to 0. Negative 14. Negative 14. Okay. Hindi. Huwag mo natin lagay negative. 14 mz minus 7 my equal to 0. And then let us i-deduct natin yung dalawa. Baliktad na lang, i-deduct na lang yung dalawa. Okay, di 4mz. Ay, hindi pala pwede. Mx pala to, mali ako. Mx. Okay, Mx. Mx. Okay, deduct natin. 14mx. Hindi pala. 14mx. Yung dulo. This will become 14 mx minus, cancel na kasi 'to, eh, minus 10 mz equal to 0. Lipat ko sa kabila, okay, mx 14 equal to 10 mz. Yan, divide natin both sides by, para makuha ko si mx, 'di ba? 14, okay? Mx will become 5/7 mz. We now have the value for mx. Okay? Pwede nating i-substitute dito. Ayan. So, 5/7 mz, yung TR3, minus TX. Okay, TX yan eh. What is TX? I think that is 9. Puro algebra lang to. MZ multiplied to 38 minus TR3. Okay, isa na lang yung magiging value dyan. We can multiply it both sides by 1/mz para ma-cancel out. Okay? Cancel out, and then cancel out. Cross multiplying by 7. Okay? So, simplify. 5 TR3 minus 45 equal to 7 times 38. 7 times 38, that is 266. 266 minus 7 TR3. Okay? TR3. Now, we can simplify both equations. So, 7 plus 5, I think that is 12. TR3 equal to 266 plus 45, 311. 311. Divide both sides by 12. Now, the resulting temperature will be, divide by 12. Now, that will become 25.92 degrees Celsius. Okay, that is the resulting temperature when Z and X are mixed. 25.92. 92 degrees Celsius. Okay. Algebra lang, 'di ba? Napakadali lang niya. How about number 15? An economizer receives hot gas at 0.27 BTU per pound degree Rankine. And the water in the ratio is, okay, may ratio 1.5 pound gas per pound water. The gas enters at 845 degrees Fahrenheit and leaves at 350 degrees Fahrenheit. Water enters at 120 degrees Fahrenheit. Find the exit temperature of water and the LMTD for the parallel flow. Parallel flow, magkasabay. If there are no external energy losses. Now, medyo complicated yung problem. Let me just read again the problem. Ayun, pound gas per pound water. Tama. So, dito, meron kang cross flow. Okay? So, that is Q ng gas is equal to Q water. Heat to heat. Kapag may dot, that is flow rate. So, water in the ratio. And water in the ratio. Okay? Okay, can be. So, the M ng gas, CP gas, tapos yung T hot ng gas, minus T low ng gas, equal to mass ng H2O, water. CP ng H2O, tapos T ng hot minus T low. Ang problema mo dito, naka-pair yung mass of gas eh. Okay? The mass ng H2O per M ng H2O. Cancel out, okay? I-cancel out na to. Cancel out mo na tong M ng H2O. Okay? Yan. Cancel this out. So, ang lumalabas dyan sa computation mo, given na pareho to, M gas, MH2O. That is equal to 1.5 pound gas per pound water. Yan. So, the best way for you to do it is to i-ano muna natin, i-solve muna natin siya bago natin i-drawing. So, for solving, yung CP ng gas is 0.27 BTU per pound degree Rankine. Okay? And then the T high is 845 minus leaves. Ayan o, leaves at 352. Sa hot gas daw yan. Degrees Rankine equal to CP ng H2O. That is 1 BTU per pound degree Rankine. Tapos meron kang T-hot dito. Ano ba yan? Ayun, ang tubig mo kasi iinit dyan, okay? Water enters at 120. So, T-hot ang hinahanap mo. T-hot minus 120. Okay? Degrees Rankine. Ngayon, simplify natin. Cancel natin tong BTU per pound degree Rankine. Cancel natin yan. Rankine ang lalabas. So, simplify ko muna to ha. Okay? 845. 845 minus 352 times 0.27. Okay? That is 133.11. 133.11 degrees Rankine equal to T hot minus 120. So, change in temperature naman yan, and then T hot will be, for water 133.11 plus 120. That is 253.11 degrees Fahrenheit. For, tama ba? Tama. Let us check. Okay. 845 minus 352 times 0.27. Okay. 133.11. Tama. Tama. Times 1.5. Kulang pa pala. Dito ko nagkamali. Hinahanap ko yung mali ko eh. 133, bali, 845 minus 352 times 1.5. Hindi ko na isama dito. Ina-cancel. 1.5. 1.5. Ayan. Dapat to buo. Times 0.27. Okay. Times 1.5. 199. Ayun, dito ko nagkamali. So, 199.665. Ayan. 199.665 degrees Fahrenheit. 199.665. Plus 120 ko na lang 'to. The answer is 319.665, tama. 319.665 degrees Fahrenheit. That is the temperature of water, okay, after ng heat exchange sa parallel flow. Ang hinahanap diyan, LMTD. So, best way for us to understand it is to draw it. Ito na naman tayo sa drawing. Parallel flow ang pinag-uusapan natin dito. Ayan. Okay. Since that is parallel flow, okay, meron tayong temperature, meron tayong length ng cross flow. Hanapin muna natin yung mainit. Okay? Magsimula tayo sa mainit. Yung mainit mo, since this is cross flow, nagsimula ka sa 845, bumaba ka to 352. Okay? Yan, ipakita natin, 352. Okay? From there, papunta rito, 352. Okay? 845, 352. Tapos, pupunta ka naman dun sa cross flow, pumasok daw. Hindi, parallel flow. Parallel flow. So, yung tubig natin from cold to hot. Yan. From cold to hot. Do-drawing mo para mas maintindihan mo siya. Okay. So, this is parallel flow. So, dito 845, dito 352, dito na yung hot ng water, 319.665, tapos dito 120. Now, for LMTD, tignan nyo, maximum dito, okay? Minimum dito. Ayan, yung dalawang to. So, equal to maximum, that is 845 minus 120 minus 352 minus 319.665 divided by the natural logarithm, okay, ng maximum and minimum. ln, mukhang pound eh. ln, tapos 845 minus 120 divided by 352 minus 319.665. Okay. So, we can now solve for LMTD. Solve natin isa-isa. LMTD, 845 minus 120 minus 352 plus 319.665. Okay? Tapos, the natural logarithm ng Tmin and Tmax. 845 minus 120 divided by 352 minus 319. Mamaya may cases tayo ipapakita dyan. Special cases for LMTD and AMTD. Kung saan kapag nag-0-0 siya, yung difference, hindi mo masosolve. May ipapakita kong technique mamaya. So, that is 222. Okay? 222 or 223. LMTD now is 222.72. Approximately 222. Hindi, 223 pala. 223 degrees Fahrenheit. Okay? That is for the cross flow parallel. Okay? Parallel pala, hindi pala cross flow. How about the second to the last problem? A metal rod, 10 cm long, has a diameter of 2 cm at one end. Is in contact with the steam at 100 degrees Celsius, while the other end contacts a block of ice at 0 degrees Celsius. The cylindrical surface of the rod is carefully insulated so the heat flows only from end to end. Ibig sabihin, this is conduction, okay? Ano po ba sa conduction? Ibig sabihin, from one end to another, yung heat transfer mo. From the hot end to the cold end. The cylindrical surface of the rod is carefully insulated so heat flows from one end to end. In a time of 20 minutes, 320 grams of ice melts. What is the thermal conductivity of the metal? So, ito yan. Special case. The ice melts. Ibig sabihin, yung bloke ng yelo mo, okay, after coming in contact with the hot rod, okay, this is your rod, okay, yan yung rod mo, okay, dito. So, this is the steam, okay. Papunta dito yung init. So, your ice will become water after some time. Okay, magiging tubig daw 'to, H2O. Now, in order for you to turn ice into water, ano bang process 'yon? Is that latent heat of vaporization? Is that latent heat of fusion? So, if you have a change in phase, then you don't have any change in temperature. Okay? That is the process of heating and cooling. Okay? On that, meron kang vaporization state and then fusion state. Okay? When you have change of phase, wala kang change in temperature. Okay? Now, when the steam, okay, or the hot rod heat transfers, okay, yung heat na yun will be absorbed by the ice. Okay? When it turns into water. Now, in order for you to turn water into ice, you just need, ano, the latent heat of vaporization. Vaporization kapag water to steam, kapag naman ice to water or water to ice, that is latent heat of fusion. Okay? That is equal to, ano ba latent heat of fusion of water? That is 335 kilojoule per kilogram. That is the energy you need per kilogram of water to turn water or to turn ice into water. Ayan. This is the latent heat of fusion. And latent heat of fusion. Okay? So, yung rad conduction yan, that is catex, di ba? Catex. Area delta T X divided by yung mass ng ice, okay? Tapos yung HF ng ice. Okay, anong hinahanap natin dito, sir? The one we are finding is the conduction of metal. The thermal conductivity of metal. That is K. Okay? K. M ng ice, HF ng ice. Simplify natin. Multiply to X divided by the area tapos delta T. Now, pwede pa nating simplify. Mass ng ice, HF of the ice, times X divided by the area pi over 4 D squared delta T. Yan. So, we can now solve for the thermal conductivity ng ice. Ano ba ang thermal conductivity of the ice? The rad. Okay? That is in watt per meter squared degree Kelvin. Okay? Meter squared ba? I think hindi. Meter. Hindi pala to film coefficient. Okay? Yan. Watt per meter degree Kelvin. So, we can now solve for K. The mass of the ice is 320 kilogram ba yan? Grams pala. 320 grams. Let me check the problem. Grams. Ayan. So, gawin natin kilogram. 0.320 kilograms ng ice per 20 minutes. Okay? Times. Naka-seconds dapat yan para maging watts. Okay? 1 minute. 60 seconds. For the mass. And then HF. That is 335 kilojoule per kilogram. I-multiply it with 0.1 meter. Bakit, sir? Ba't naging 0.1 meter? Ayan, no? Other end, 10 cm long. Diba? The length is 10 cm or X. 10 cm. 10 over 100. 0.1 meters. Okay? Divided by the area, pi over 4. Ano yung D na binigay dyan? I think 2 cm. Okay, 2 over 100 meter squared. Tapos from 0 kasi ice, tapos 100 degrees na minus 0 degrees Celsius. We cancel all the same units. Okay? Kilojoule, minute, okay? Kilogram. That is watt. Okay? Pwede natin isolve. Kilojoule, multiply na lang natin dito ng 1,000 joule. Okay? 1 kilojoule. Para ma-cancel natin. Joule per second is watts eh. Yan. Kilogram, kilogram. Yung meter, yung meter, yung meter. Kilojoule, kilojoule. Minute. Joule per second is watts. Okay. Let us solve. 0.320. 0.320 times 335 times 0.1 times 1,000. Okay? Tapos meron tayong 20 times 60 sa ilalim times pi over 4 times 0.02 squared times 100. What will be the answer? Uy, may mali. Ayun. That is 284. Okay. The conductivity will be K is 284.3568 watt per meter degree Kelvin. Okay. Ganun lang kadali. How about the last problem? A counterflow heat exchanger is used to heat a cold fluid from 150 degrees Fahrenheit to 320 degrees Fahrenheit. Assuming that the hot fluid enters at 530 degrees Fahrenheit and leaves at 360 degrees Fahrenheit, calculate the log mean temperature difference for the heat exchanger. So, counterflow ito. I-drawing muna natin para mas maintindihan. Ayan. So, ano yung pinakamataas na temperature mo dyan? That is 530. Palagay natin. Counterflow. This is 530. Pag counterflow hot fluid, laging papunta rito yung hot fluid through the length. Okay? Okay, this is 530. This is 360. Okay? Tapos, blue natin yung maliliit. Blue. 320 to 150. From 150 to 320. Counterflow eh. Map na natin to. This is 530 and leaves 360. 530 to 360. Yan, papunta riyan. Yung fluid mo, it will leave at 360. So, counterflow, nandito. 360. Tapos, 320 tapos 150. Ba? 360. Konti lang yung inangat niya. 320. Ayun. 320 dito. Tapos, 150. Punta riyan. Yeah. Ayun. Pabaliktad. So, yung delta T dito, okay, tapos yung delta T dito, yung delta T dito, and then delta T dito. Makikita mo naman, nandito yung max eh. This is 530, this is 360, okay, this is 320, this is 150. Let us see yung temperature difference nila. LMTD. Yan. So, this is 530 minus 320 minus 360 minus 150 divided by what? Divided by loan ng 530 minus 320 divided by 360 minus 150. Solve natin, okay? Para makita natin. So, 530 minus 320. Simplify mo natin. 530 minus 320, I think that is 210. Okay? And this is what? 360. Oh, 210 din. Tapos dito, 210, 210. Sir, wala pong natural logarithm of 1 and 0. 210 minus 210 is 0. 210, tapos tignan nyo yung loan ng 1, that is 0. Okay? ln 1, that is 0. Okay? And anything that is divided by 0 is non-existent. Okay? But, wala pong tamang sagot, sir. Wala sa choices. No. There is always a correct answer pagdating dito. Let me tell you. Na kailangan, okay, this is approaching sa value ng 200, 210, slim chance, okay? Napaka-slim nung number. Kailangan gagawin mo, it's either 209.9999999 or simply 210.0001 up to 10 thousandths of the decimal. Okay, ganito gawin natin. So, this is 210.0001 minus 210 divided by the loan ni 210.0001. Enough na yon. That is 10 thousandths. And then 210. You can get a value for LMTD. Okay, tignan natin. So, the value is 210.0001 minus 210 divided by the loan 210.0001 divided by 210. You can get an answer with that. So, the answer will be 210 degrees Fahrenheit. Okay? So, may nakuha ka. Unlike dito, this is 0, di ba? Or 1. ln at 1. That is 0. Yung lalabas dito. Now, meron tayong nakuhang value. 210 degrees Fahrenheit. That is the LMTD. How about, sir, pwede bang gawin namin 209? Pwede. Subukan natin. Okay? Pero kasi, 210 na yan. Okay? Gawin natin. Approaching to 210. 209.9999. Tapos dito sa taas. 09.999999. The answer is still the same. 210. Ganun pa rin. Okay? So, that is for the final problem and the last number for your e-transfer. So, after this, meron tayong 10 exercises to be answered. Okay? That will be all. Have a nice day. Bye-bye.